Hello, algebra students. Mr. Lawrence here with a very sore throat. I'm going to try to make this video as quick as possible, but rest assured I have not been abducted by aliens and replaced with a cooler, much hipper teacher with a better voice. No, this is just me with a cold. Anyway, there we go. A little hamming it up for you. All right, so today in class and yesterday in class, we've been factoring. And we learned that we already know, we didn't learn today, we already know how to factor by GCF. Now some of you are having trouble with this. They're saying, I can't find the GCF. It's like, come on guys, that's like a 5th grade skill. You can do that. Find the GCF. Remember, the GCF of variables is always the lowest exponent. Always. Okay? The difference of squares, right? You have a perfect square minus a perfect square. For example, something like this, if I have 25x squared minus 49, that would factor real easily. What would we have? 5x plus 7 and a 5x minus 7, because that's the difference of perfect squares. GCF situation might be 3x to the 4th. Hold on, I want to change that 3 to a 9. I want to make that a 9x to the 4th. Okay, minus 3x squared. Okay, now the GCF in this one looks like it would be a 3, right, and an x squared. So I'm going to factor out a 3x squared. What some of you aren't doing, like you're just trying to do stuff in your head and you're not getting it right, is you're forgetting to divide these by the GCF. Okay, now don't lie to me here. I had some people lying to me trying to tell me that 3x squared divided by 3x squared is 0. It is not. Bite your tongue. Not true at all. So let's see. 9 divided by 3 is 3. X to the 4th divided by x squared is x squared. Okay, and then of course 3x squared divided by 3x squared is minus 1. Right? Okay. Now, this part in here sometimes can be factored more. And many of you are having trouble with that. You think, oh, I'm done. I pulled out the GCF. Oh, there's more to it sometimes. Now, in this case, it almost looks like the difference of perfect squares. 25x squared minus 49. Only problem is 3 is not a perfect square. So it is not the difference of perfect squares. Okay. And then the one we learned today was the perfect square trinomial. And we will cover those in this video, so that those of you that are absent can take notes and hopefully catch on to what was going on. But with a perfect square trinomial, we end up, the first term and the last term are both perfect squares. And what we noticed, the middle term ends up being twice the product of the square roots. So this would be a 2x, this would be a 5. If I multiply those two square roots, 10x, and double it, I get 20. This factor is real easy. 2x and a 5, and a 2x and a 5. And then, since this is positive, this sign shows up twice. Okay? Now, I will explain more about that later. That's just a quick overview. So you can decide how much of this video you need to watch. If you were in class today, you can watch it casually. Pay attention to the parts that give you trouble. All right, I'm going to do number 1, and then I'll expect you to do number 2 on your own. All right, I'm going to find the GCF. I'm going to find the GCF of 2x to the 4th y squared minus 16x squared y cubed and 44xy. Well, the GCF of 2, 16, and 44. I see some people doing some ridiculous things, writing out all the factors of 16, all the factors of 44. You can do it that way, but it takes forever. I'm going to pick the number with the least number of factors, if I can tell. And sure enough, 2 is going to have the least number of factors. Right? The factors of 2 are 1 and 2. All right? Now, if the GCF is 1, it's not going to do me any good. There's nothing I can do. So I'm going to see if 2 goes evenly into 16. It sure does. And does it go into 44 evenly? Yep. So part of my GCF is 2. Now I need the GCF of the x's. Looks like I have an x to the 4th, an x squared, and an x. So the GCF of the x's will just be x. Why is it just x? It's always the least exponent, right? Okay, and then the GCF of the y's, okay, is going to be y. See, there's 2 y's being multiplied here, there's 3 y's there, and there's 1 y there. So the greatest number of y's they have in common is y. There's not a y times y over here. Okay, so my GCF is going to be 2xy. So I'm going to divide this by 2xy. I'm going to divide this by 2xy. And I'm going to divide this by 2xy. Now, since this isn't an equation, that GCF has to be out front. I pull it out, I divide it out, and then I simplify. And so the 2's are going to cancel. I'm getting an x cubed and a y, right? X to the 4th divided by x, and y squared divided by y. X cubed and y, and these cancel to 1, not to 0. All right, 16 divided by 2 is 8. X squared divided by x is x. Y cubed divided by y is y squared. All right, and finally, this last term, 11. Oh, no, 22, silly me. 22, sorry about that. All right, so that'd be 44 divided by 2 is 22. The x's cancel and the y's cancel. This is completely factored. This cannot be factored anymore. That's all you can do is pull the GCF out. All right, I want you to pause the video and try number 2 on your own. I'll show you my solution here in a second. Okay, here comes my solution. If you haven't done it yet, I'm going to get a 3xy as my GCF. When I factor it out, I'm going to get a 4y to the 6th minus a 6 x to the 5th y to the 4th. Am I done? No, there's a +1 here. Remember that when you divide, it doesn't divide to 0. The only way a division problem can equal 0 is if the numerator is 0. If I have a divided by b and it equals 0, then I know a must equal 0. Take any other 2 numbers for a and b. You cannot get 0 out of it. Is 1 divided by 5 0? Of course not. That's ridiculous. How about 17 divided by 34? That doesn't equal 0 either. The only way to get an answer of 0 in a division problem is to take the number 0 and divide by a non-zero number. This would be 0. Okay. This would be 0. This would be undefined, right? Can't ever divide by 0, so we're not going to do that. Okay. So now the difference of squares. All right. So remember, we have to have a perfect square, 2 perfect squares, and a subtraction problem. Well, let's see here. I've got 25x squared. That's a perfect square. The square root is 5x. And 36 is a perfect square, and that's 6. And it is a subtraction problem because the signs are different. That one's positive, that one's negative. This is going to factor real easy. Okay, so we're going to get a 5x, a 6, a 5x, and a 6. And when the last term is negative, we get 1 of each sign. When the last term is negative, we get 1 of each sign. When the last term is negative, we get 1 of each sign. All right, so I want you to try number 4. But remember, the first type of factoring you should always try, and 5, is GCF, okay? Pause the video, try 4, see if you get it right. All right, here comes my solution for 4. So first of all, there's a GCF in here. I think my GCF for number 4 is going to be 6x. So I'm going to factor out a 6x, which means I'm going to divide by 6x, I'm going to divide by 6x. Well, that's going to be x squared, and that's going to be 54 divided by 6 is 9, and the x's cancel. Now, many of you are stopping here, but what you're not realizing is inside this quantity, right here, x squared minus 9, that's the difference of perfect squares. It's 2 perfect squares, and it's a subtraction problem. So the square root of x squared is x. Square root of 9 is 3. This is going to factor like this. We're going to have 6x. The GCF comes down. We're going to have 2 quantities. Okay, both quantities will have an x and a 3. X and a 3. Since the last term, the 9, is negative, I'll get 1 of each sign. And there you go. All right, pause and try number 5. and I will give you my answer. Okay, GCF is going to be 3x. I'm going to factor it out. I'm going to get a 4x squared minus, don't you say it, Alex, minus 1. Right? Now I look inside. Can this be factored more? Well, I've got a perfect square. 4x squared is, fair square root is 2x. 1's a perfect square. Okay? So I'm going to go 3x, and then I'm going to get two quantities. How do I know they can be factored? Because it's two perfect squares and a subtraction problem. 2x plus 1 and 2x minus 1. So this is all review up to this point. Here comes the new stuff. The perfect square trinomial. Now, if you were in class on Tuesday, you saw how we did this, okay? If you didn't, I want you to double distribute. I want you to multiply the 2x by both the 2x and the negative 5, then multiply the negative 5 by the 2x and the negative 5. Go ahead and do that for me, and then do the same thing for the second problem. Make sure you're double distributing. Okay, you should get 4x squared minus 20x plus 25. And on this bottom one, you should get 16x squared plus 56x plus 49. All right. I don't know if you noticed this, but there's an awful lot of perfect squares in these problems. This is a perfect square, and so is this. This is a perfect square, and so is this. Watch what's going to happen. This is pretty cool. If you were in class, you already saw this. Square root of 4x squared would be 2x. Square root of 25 is 5. If I multiply these two together, I get 10x, and if I double it, I get 20x. That's not a coincidence. It makes this factoring really easy. Okay, the square root of this is 4x. Square root of 49 is 7. Multiply them together, you got 28x. If I multiply that by 2, or in other words, double it, I will get 56x. These two here are called the perfect square trinomials. Perfect square trinomials. Okay, perfect square trinomials. So, let's look at number 8 and 9. And I got 10 and 11 on here. So I will do two of them and let you try two of them. Okay, I have a trinomial. The GCF is only 1, so it's not going to help me. This is a perfect square, so is 16. I'm going to find the square root of 9x squared. That'll be 3x. Square root of 16 is 4. Okay, we are going to get two quantities when we factor this. We're going to get the 3x and a 4, 3x and a 4. Now, since the 16 is positive, I'm going to get that sign twice. The negative sign on the 24 will show up twice. And this is factored. You can check your work by double distributing. I highly recommend that you check your work by double distributing. It's a great idea. All right, 9. I've got a trinomial. I don't have a perfect square trinomial because 75 is not a perfect square, neither is 12x. But I do see a GCF. It looks like my GCF. Uh-oh. Oh, there we go. Okay, my GCF. All right. Well, I'm going to list the factors of 12. 1 and 12, 2 and 6, 3 and 4. And now I'm going to test 75 and 60 to see if any of these numbers go in. Well, 12 does not go into 75 evenly. It goes into 65 times. 6 12s would make 72, so it's not going into 75 evenly. 6 goes into 60, but it does not go into 75. 4 does not go into 75. 3 goes into both of them, 75 and 60. So part of my GCF is 3. Now if I look, I've got an x cubed, an x squared, and an x. That means the GCF of my x's is x. So I'm going to be dividing each term by 3x. All right, so I pull the 3x out front. 75 divided by 3 is 25. X squared divided by x is, x cubed divided by x is x squared. 60 divided by 3 is 20. X squared divided by x is x. And 12 divided by 3 is 4. X divided by x is 1. Now, don't stop here, because if you look closely, you look in that quantity, you will see that we have a perfect square here, and we have a perfect square here. If you find the square roots, multiply them together and double it, and you get the middle term, you have a perfect square trinomial. So the square root of 25x squared would be 5x. Square root of 4 is 2. Multiply together is 10x. Doubled is 20. This is going to factor just like this. We're going to have a 3x out front. That's the GCF. Then we'll have two quantities. Both quantities will have a 5x and a 2. A 5x and a 2. Third term is positive. The middle sign will show up twice. And there you go. Factored completely. All right, here's number 10 and number 11. I want you to pause the video and try them on your own. Okay, I'm going to show you my answers here in a second. All right, here comes number 10. I'm going to have a GCF of 4x squared, leaving 9x squared minus 6x plus 1. Is that thing inside the quantity a perfect square trinomial? You bet your life. That'll be a 3x. That's a 1. Multiply together, get 3x, double, I get 6x. We're going to have 4x squared. Two quantities. 3x, 1, a 3x, and a 1. It's positive. This sign shows up twice. Boom. Boom, I'm done. I just factored it completely. Okay, number 11. If you haven't tried it yet, go ahead. I think it's a perfect square trinomial. This is going to be 6x. This is going to be 5. I multiply them together, I get 30. Double, I get 60. This is going to factor as 6x plus 5 times the quantity of 6x plus 5. The GCF of that trinomial was 1, so I didn't need to worry about writing it down. Okay, I hope that helps you. Nadia, this was for you, so if you want to come in at Pride Time tomorrow, just let me know. We can get a little more extra practice. Hopefully I'll be feeling well enough to be at school. All right, Mr. Lawrence signing off. Have a good night, everybody.